I work for Tech Systems Global Services. So Tech Systems are a services organisation. We help organisations, digital transformations, that sort of thing. I lead the Agile practice there. So I get involved in actually most things, because most things are transformations one way or the other. So we have a team of people, and we have a kind of pool of consultants. So that's my day job. But yeah, I've been in and around Agile for 20 odd years now. Kind of was lucky enough to get involved in the early days, and then through Kanban, agenda shift. I guess my big interest at the moment is strategy and strategy deployment, and how, which is really just broader than Agile. It's just how do we help Agiles? How do we help organisations with strategies, have strategies, deploy those strategies so those strategies are effective, and we can effectively do strategy in an Agile way, is the way I think about it. Part of that, and I'll kind of come back to this, is it kind of got me thinking about predictability. So before I kind of talk a little bit about what I think predictability is, so what kind of predictability? So when I talk about predictably agile, what comes to mind when you hear that phrase predictability? What kind of predictability? So put your answers into Mentimeter, and then we should see what sort of things come up. Yeah, on time. Ooh, velocity. Interesting. Beautifully boring. Okay, yeah. Consistency of output, delivery on time again. Common highs and pitfalls. Yeah. So that ties a little bit back to consistency, I think, kind of common highs, consistency of highs and consistency of pitfalls. Okay, we'll talk a little bit about estimation as well, velocity. Deliver what we thought we would. Yeah, that's kind of quite a nice definition. Reliable. Yeah, I sometimes kind of switch between talking about reliability and predictability. I think there's a kind of a subtle difference. I might talk about that at some point. Outcomes. Was that you, Andrew? No. Okay. So yeah, there's some kind of common themes there, aren't there? I mean, any kind of what kind of jumps at anybody as we're actually in person? We could have a bit of conversation. What jumps out of people looking at those answers? Anything? Trust. Okay.
All very predictable, aren't they?
Very good. Yes. Anything else? All right. So I'll kind of go back. Let's kind of look at what the dictionary says. So interestingly, the dictionary has two definitions of predictability. Capable of being predicted, which is able to be known, seen, or declared in advance. I think quite a few refer to that as like, how do I know what I'm going to get and when I'm going to get it? And I think that's what most organisations think about when they're talking about predictability. We want to be more predictable. We want to know what we're going to get and when we're going to get it. So we want to be able to know in advance, or see in advance, declare in advance what's going to be delivered, etc. More interesting, I think, is the second one, which is behaving in a way that is expected. So rather than thinking about it in terms of the work, we can think about it in terms of the behaviour and the behaviour of the system. So that's kind of the angle I want to try and take this down, is let's think about predictably differently, and rather just think about it in terms of having a plan, delivering to the plan and kind of delivering on time. Let's think about it in terms of understanding the behaviour of the system, and therefore understanding outcomes, what outcomes that system is capable of delivering, and therefore what can we do with that information. So that's the kind of the way I think about predictably can be seen as a bad thing, particularly in Agile. So somebody put there about beautifully boring. There's the argument. It's not an argument. I kind of agree with it. We don't want to be so predictable that we're mechanistic about it. We're not manufacturing. We're doing product development. We're doing learning. But I think we still can be predictable within that product development, high learning environment. And the reason I got into this is because when I go in and talk to organisations, ultimately my goal is not to get an organisation just to do Agile for the sake of it. I want to help them with Agile because I think it's going to help them to be more successful as a business. So business success is the focus. And then you kind of say, well, what do we mean by business success? And I kind of like to talk about these 6 areas. So these kind of come from the kind of combination of a guy called Larry Mascheroni and Troy McGuinness and the work that those two have done. Value, productivity, predictability, responsiveness, quality, sustainability. So for 5 of those six, I can talk about what I mean by those things. So responsiveness is how quickly can we deliver work. So we can talk about cycle time. There's some kind of quite good measures that we can talk about there. Sustainability, are we able to do this in the long term? We can look at things like, one, the human side of it. Are people happy? If people are happy, if people are enjoying their jobs, or even if people are leaving their jobs, if you have a high employee churn rate, that's probably not sustainable. Or you could look at it from a code quality point of view and maybe get some static code metrics and look at the cyclometric complexity or things like that. So you could probably do some analysis of the code base and kind of think, do we have a well-factored, well-designed, well-architected code base that's going to allow us to keep working on it? Maybe number of tests could also be a measure of sustainability. So I think there's a number of areas that we can measure for that. Value, value is always subjective, but hopefully an organisation should be able to talk about what value means to them, and usually it's in terms of kind of some form of revenue, or units sold, or customers, or repeat customers. So there's some way we can kind of figure out, are we delivering the right work? And then quality, we can look at defects, we can look at escape defects, we could look at maybe customer support calls. Customer satisfaction, maybe, kind of might relate to quality. Are people happy with what we're delivering? So are we delivering work in the right way? Kind of talk about that. Productivity, how much work can we deliver? Can we deliver work in quantity? Typically we kind of talk about throughput, number of features we're delivering, or number of user stories we're delivering, or number of releases we're making. We can kind of put some numbers around that. And then we get to predictability. Is work delivered consistently and reliably? And I realised I never really had a good answer to how would you measure that? What do we mean by predictability? So this talk is a little bit of a kind of a deep dive into my thinking behind how do I answer that question. If I'm going into an organisation saying, I think you can be more predictable, how would I prove that? What measures would we take that we can kind of go, yes, these are your numbers to start off with, these are the numbers now, we think you're more predictable. This is all a bit of a hypothesis. So I've played around with some of this. I've talked to people about it, but this isn't a case study, and I don't have any hard data behind this. It is really just kind of a bit of a thought experiment. But hopefully, my kind of goal is to kind of explain the hypothesis to you, and then we'll see at the end whether you think it's plausible or not. Okay, so let's dive into it. I will say I've been known to do this talk in about 20 minutes. I kind of get a bit excited about it, so I'm going to try and take my time. If you think I'm rushing over anything, we are going to go into some metrics and numbers and statistics and data. I'm not an expert mathematician, so hopefully I'll kind of explain it, keep it high level. But if I'm going too quickly and I'm not explaining things well enough, just let me know, and I'll slow down and I'll go back. But before we get into that, I'm talking about the most common form I see of predictability measures, which are kind of called say-do measures. So I want to mention these because, elephant in the room. I think the crime scene is maybe over-egging it. I don't think these are really that bad. But kind of caution to be applied here. They're useful, but I don't think they're about predictability. So the first one is velocity. So velocity came up when we were talking about in the little Menti at the top. What's our velocity predictability? How many points do we deliver compared to how many we said we were going to plan? So this is a screenshot from Microsoft Azure DevOps. So you've got the number of planned stories, the number we actually completed, the number maybe we completed late, and the number we didn't complete. And this is called velocity predictability, but you'll kind of see this example is doing a count of work items. So at least this is, if you don't like velocity, at least this is just kind of not falling into that trap. But it's one way of looking at it, like how good are we at planning? Now I'd argue that actually that's all this is telling you. It's like how good are we at planning? It doesn't really tell you anything about your long-term predictability. Now, if you've got teams, and so who's a coach in the room that's kind of working with teams, you kind of see teams where actually they've consistently, and I quite often say this, teams are predictable because I can predict that they will plan 3 times as much work into a sprint that they can actually deliver. And that's why I sometimes prefer to talk about reliability to predictability, because like you're a really predictable team because you will reliably never deliver. So this can be useful in those kind of things. It's like if a team's really, really, really bad at that kind of short-term planning and they need to get some data around planning the right amount of work into the sprint so they don't overload themselves, it's useful for that. But yeah, it's more a kind of a reliability metric than a predictability metric if we're going to be kind of pedantic about the language. So that's just one way of looking at it. And then SAFe takes that to another level and talks about program predictability. People who's familiar with SAFe and its program predictability? Okay, a few people. So I'll explain this. So SAFe has the program increment, which is like a meta time box. So it's usually about 6 sprints. So sprints equals the PI, and you deliver a number of features over those 6 sprints. And the idea of program predictability, just like velocity predictability, is how good are we at planning a number of features into a PI to deliver business objectives. So in SAFe's favour, at least it does this with objectives and not features. So it takes the features and says, what's the objective behind this feature? So it's trying to focus on outcomes. And then it scores those features. So we've got a set of objectives. So it scores those objectives in terms of a number of 1 to 10. So that's kind of where it starts going a bit pear-shaped in my book, because now we're kind of back to kind of arbitrary, abstract numbers. But okay, we've got these objectives. We don't score the uncommitted ones. So we've got this amount of business value that we think we want to deliver this PI. And then at the end, the business owner will kind of go, well, this is what you actually delivered. And then we can track the percentage of actual value compared to planned value, and say how predictable we are that way. And SAFe has this notion that, yeah, you probably don't want to be delivering 100%. So then going back to velocity, if you've got a velocity predictability of like 100%, you're kind of always delivering, then you're probably not stretching yourself. So there's, or you're just playing the numbers. So SAFe at least has this notion that, maybe 80% is a good target. It's possible to deliver more than 100%, but below 80%. Again, if you've got teams or programs, release trains, whatever you want to call them, that really can't figure out how many features do they plan into a PI, it's useful for that. But again, it's more about the reliability of planning than it is about the predictability. So the two main problems with that is, one is, I think it's kind of, there's a confusion of correlation and causation. Except it's kind of inverse to the way we normally talk about it. So if you think about the theory is that if we get good at reliable short-term planning, we will be predictable in the long term. I don't buy that. I don't think that works. So I think there's kind of a mismatch there. We're focusing on the wrong thing, and I don't necessarily agree. Obviously, we want to be good at planning in the short term, but I don't think it really tells the business about how predictable you are going to be in the long term. So that's one problem, I think, is kind of that getting a little bit confused between correlation and causation. And the other one is the fact that generally you're just dealing with made-up numbers. Particularly if you're in velocity, is just a made-up number. That I think that putting scores of 1 to 10 against objectives had a bit of a conversation. I think there was a conversation with one of the SAFe fellows about this, because they was kind of talking about say-do and kind of going, you shouldn't do say-do, and I kind of went, well, isn't that what SAFe's doing? So we had a bit of a to and fro, and the usual answer is, yeah, but it's all about the conversation, it's not about the numbers, which I kind of agree with, but then you're into, well, why have the numbers in the first place? But yeah, you kind of end up just with these made-up numbers, and then you're just playing and gaming the numbers, and again, it's not really helping you as a business become more predictable. So that's my take on it. So useful things to know, but it's not. It's more reliability, short-term reliability, than it is long-term predictability. So what do I recommend instead? So I started with cycle time variation. So cycle time is that idea of how long does it take us to deliver something. The clock starts ticking when we start working on it. Clock finishes ticking when we delivered it. What's that elapsed time in between? If we wanting to think about when will something get done, that's basically what you want to know. How long is it going to take? So let's just measure how long it takes us to do stuff and see if that tells us about how long we think it's going to take us to do new stuff. So that's what cycle time variation does. Now this is a kind of a debate I had with Dan Vacanti, if people are familiar with Dan. So read Dan Vacanti's book. He talks about a lot of this stuff in much more detail. And he kind of challenged me because he kind of said the notion of improving predictability doesn't exist. So it's just like you're just on the wrong foot to start off with. And he's basing that on Deming. So Deming said a process that is not in statistical control has not a defined capability, its performance is not predictable. So Deming is saying if you have a system that's in control, you can predict the way that system will behave. It is predictable. Predictability is therefore Boolean. You're predictable or you're not predictable. So like, how can you improve something that's Boolean? So that was like, okay, well, I agree with Deming. I'm not going to argue with Deming. On the other hand, I still think there's this idea of like you go into an organisation and you kind of go, what would you like to improve? A lot of CEOs say, I want to be more predictable. So what's the kind of the challenge there? And I'll come back to that. But part of the other shift is this kind of move to thinking about things more probabilistically and less deterministically. So rather than, a plan is usually a deterministic thing that we kind of go, we're going to do A, B, C, D, E in that order. We'll execute the plan and we can determine when we're going to finish. And what we're going to do is move to probabilistic thinking, which is rather than saying we know exactly when things are going to do, we're saying there's a probability of us doing something by a particular date. So if we understand the probabilities around the system, we can be more predictable. So that's kind of the start and the way I was kind of thinking around how do we talk about predictability and start measuring it. So this is where we kind of start getting into some of the detail. So this is, anybody seen this cycle time scatter plot? So this is from Actionable Agile. I've got lots of screenshots from Actionable Agile. I don't work from them. I don't get any money from them. I just really like it as a tool, and it's really easy to get screenshots from. So here's my hypothesis. Let me explain it. Each of these dots represents when a piece of work got done. Where it is along the bottom tells you the date it was completed. So these ones here are kind of beginning of April 2022. How high it is represents the cycle time. So this one here that's on the line has a cycle time of 10 days. So 10 days between starting and finishing, finished around about the beginning of April. So we can now start seeing a pattern of the dots of all the work we've finished in the past. And we can then start doing some maths with that. So here's my hypothesis. So this is kind of when going back to what does it mean to be less predictable, more predictable? I think, and I've put predictable in quotes, and this side of the chart is less predictable than this side because you've got a greater variety of kind of data points between the maximum and the minimum. Here they're more squeezed down, so they're more consistent. So what does that mean in terms of predictability? So that's less consistent than this side. So more consistent is more predictable. But actually what we mean is that's less useful for making predictions, and this is more useful for making predictions. So that's the way I kind of agree and disagree with Deming at the same time. It's like, yes, a system is predictable or not, but how useful is that predictability? Because if I kind of say to go to a CEO and kind of going, well, I can predict that we could do this piece of work between 1 day and 1,000 days, great, predictable, but not very useful because they're going to go, well, I still don't know when it's going to get done. Could be between 1 and 1,000 days. Whereas if it's we're going to get it done between 1 and 10 days, that's more useful. And now we can start doing some planning on that.
I wonder if Deming would say on the right, that system is in more statistical control.
No. No, he would say they're equally in statistical control.
Okay.
Well, you probably do some another analysis to look at Six Sigma and Three Sigma and all that kind of stuff. But no, he would say they're both equally in control. They're both equally predictable. Just because there's a consistency. So there's an assumption here that something happened here that changed the system that has led to that. But assuming that they're two kind of different systems, no, they're both equally predictable. From Deming's perspective, but to me, what's more interesting is how useful is that predictability. So how do you measure that? How do you kind of show that? So So one of the things you can do with this cycle time is you start looking at percentiles, and this is where we start getting into probabilistic thinking rather than the deterministic thinking. We can say there's this line here that charts is that 85% of the dots are below this dotted line, which means there's an 85% of chance. Well, what's that saying is 85% of the work in the past has been completed in 16 days or less. And therefore, as long as the system doesn't change, probably 85% of the work will get done in the future in 16 days or less, given the same system, the same mix of work, same team, you know, some level of consistency there. So we can start making predictions. Now again, what it doesn't tell you is what work's going to get done. What work will get done within 16 days, and which work is in that 15% that's out down. We don't know that, but we can still kind of go. We've got an 85%, and when we start a piece of work, there's an 85% chance of it getting done within 16 days. The other thing, and the thing that kind of gets less talked about here, we can say there's a 20% chance of work being completed in 2 days or less. Again, 20% of the dots are on this line, on this line or below it. The reason it's 20%, 85% is just because I couldn't get it down to make it, say, 15%. And the 85% and 20% are kind of reasonably arbitrary numbers. It's just kind of it's like, what sort of confidence interval do you want? So that means there's a 65% chance of work being completed between 2 and 16 days. So that's kind of starting to talk about how predictable we are, not just how long things are going to take, but how short things might take. So again, that could be between 2 and 2,000 days. Not very predictable. So one of the things I did to play around with this idea is, if that gap is narrower, does that mean our system is more predictable or more useful for making predictions? So I basically took that data set, because Actionable Agile allows me to export the data set, did some number crunching on it to basically half the lead time of everything, re-put it back in, and so we can now see the 85th percentile is now 8 days, and the 20th percentile is now 1 day, so now a 65% chance of work being completed between 1 and 8 days. So my hypothesis, therefore, is it's more predictable to be able to say between 1 and 8 than it is between 2 and 16, because we've narrowed the range. That makes sense? Just kind of pause for people to...
So the predictability is all based off of historical data, though, isn't it? So,
yes.
There are other factors which change the cycle time.
Yeah, but if you get, and you don't need a large enough data set, if you've got a stable system and it's a mix of work, but there's an assumption there that the mix of work in the future is going to be similar to the mix of work in the past. So yeah, but that's why it's not 100%. That's why, part of that 15% might be this outlier, massive piece of work that just comes in, or has some unexpected dependency or thing that you've never come across before happen with it. That's why we're not saying 100%. But probabilistically, assuming work in the future is similar to work in the past, that numbers apply. Yeah. But also, there's a sub point there, is you need to be continual. You don't do this once. You need to be continually forecasting, so that as that range shifts, so your forecast shifts with it.
What kind of sample set would you take?
I normally look back, I don't know, 1 to 3 months. I think if you start looking too far back, then you're more into a risk of including data that's now not relevant. But if you look too short in the future, then maybe you've not got enough representation. Again, there's no right answer to that. I think people like Troy would say it's good enough if you've got 20 data items, between 10 and 20.
Calculate a confidence interval, you need 30 data points or more. Otherwise, it gets much more complicated mathematically.
Okay. I think there's another mathematical. So this is where I'm not a mathematician, so I don't know, so I can't really answer the question. But there's a story about tanks in the army, back in the World War II, I presume it was, and they predicted the number of tanks the German army had from a sample size of like 2 or 3. So actually, I think it's a lot smaller than that. But yeah, you get high confidence with a small number of data set, and then it's going to go up, and then it'll start tailing off. So there's probably a kind of a curve there of the point at which you're hitting diminishing returns. It's kind of interesting to look into, and there's some Troy has some exercises which use rolling dice, where you can start how many data points from dice rolls do you need before you can guess the total that you're going to get at the end when you've rolled 10, I think, something like that. So yeah, that was my hypothesis, that if we kind of start narrowing the gap, when we can do some number crunching around that. So my first hypothesis was this, what I call cycle time inequality. So this was based on the idea of income inequality that somebody pointed me to. So in income inequality, they take the P90 and the P10 of incomes, and the wider range of that income. So it's the ratio of the upper bounded value of the 9th decile, that's the P90, to the lowest decile, or it's the other way around, P90 and P10. So if they look at those ratios, the wider they are, the difference of ratio. So if we see those ratios, those numbers getting closer, we should see a different ratio when we can measure that ratio. So that was kind of my hypothesis. So we can do that. So we know from that data set 1, our P85 is 16, our P20 is 2, so our cycle time inequality is 8. Data set 2, our P85 is 8, our P20 is 1, our cycle time inequality is still 8. So I kind of disproved the hypothesis on that one. And it was like a bit of I'm just kind of squeezing it all together, but actually the ratio is staying the same. So that was a bit of I could have seen that in advance. But this is why this is all kind of playing around the hypothesis. So cycle time inequality doesn't really work as a way of doing it. The other one then is cycle time coefficient of variation. And this is where you're going to have to trust me on the numbers unless you're really good at maths. Standard deviation to the mean, variation of relation to the population of the mean. So it looks at the population of the mean around that population, the variation around that mean. So data set 1, standard deviation is 7.33 and the mean is 9.37. Trust me, I did double check this multiple times. Cycle time coefficient of variation of 0.7. Data set 2, you might not be surprised, it's kind of fairly similar. And again, it's a bit of because you're lowering the mean and you're lowering everything else. So really, even though everything's narrower together, because everything's shifted down, the scores you get, it doesn't really tell you anything useful. Now, I still kind of think that what I did in halving everything was really artificial, and these could be useful, but the fact that there's like this one example or one scenario where it's not going to work is like, it's not worth pursuing. So I was kind of a bit stuck at that point, because I still have this notion that there's something we can use cycle time for. So that made me to kind of look at, well, what are the leading indicators? So cycle time is effectively a lagging indicator, because you measure it after you finish the work. So is there anything we can do with a leading indicator that's going to tell us that things are taking a long time, which there is? So just if you're not familiar with the terms lagging and leading measures, one, this is kind of a book recommendation, one of my favourite books on strategy, which focuses more on strategy execution, but they have some really nice definitions of lagging measures and leading measures. So lagging measures, the tracking measures of the wildly important goals. So they talk about your strategy should have a wildly important goal, but that's a lagging measure that you're tracking, and the kind of the ones that kind of you spend more time praying over are the ones that keep you up at night. Those are the kind of the big things, but they're an outcome measure. They're the thing that happened when you've done the work, after you've done the work. The lead measures measure the most high-impact things that you can do to reach that goal. And they're kind of two characteristics, predictive and influenceable. So you predict that the leading metric will lead to realizing the lagging metric, and the leading metric is something you can do something about. Because usually these big lofty lagging metrics, you can't influence them. So much there's complexity to do them. Narrow it down to something where we think that if we work on the leading metric, it'll lead to the lagging metric. So I've seen recently leading metrics talk about action metrics, things that you can take action over, which will lead to the output. So using that as a kind of frame then, if cycle time is the lagging metric, what could be the leading metric that we could start say, well, if we're influencing the leading metric and the leading metric is getting better, then we can still say with confidence that we're being more predictable. So what we're trying to do here actually is make these ones that take a long time shorter, and what we don't want to do is make these ones longer. So one way, again, going back to those previous methods, one way you could kind of narrow the band is just take more time on these. So everything takes longer, but within a predictable range. Probably not really what we're trying to get to. So we're trying to make the long cycle time items get done more quickly, and keep the ones that we're doing more quickly still doing them more quickly. So that's kind of gets us into a little bit, and the first time I've put a Monte Carlo simulation slide in this talk, I was like, I don't want to spend too long on this because it's a whole other kind of rabbit hole. But what we're trying to do is really increase flow. So I guess that's the hypothesis. If we're getting these things done more quickly and getting lots of things done really quickly, we're going to have good flow. Good flow leads to good throughput. So what this is actually showing is a Monte Carlo simulation that uses throughput, which tells us a 50%. So I think this is a Monte Carlo that's showing me when will I get a certain number of items done. There's a 50% chance of kind of clearing the backlog at this date, 70% chance, and this is partly what businesses really want. They want to know when I'm going to get done, not for a single item, but for a group of items. So we can use Monte Carlo to kind of go 85% chance of getting done by, this is kind of March 2022. And Actionable Agile has this kind of nice little calendar view of that, which I think is a little bit easier to consume, where you can see really good chance. So that 95 plus is up to there, amber, red, etc. But that's really what we're trying to get to. But to get that fast flow, we need to be getting work done more quickly. So we can use aging work in progress. And this is another complicated looking chart. And this is basically telling us how old are things that we've started but not yet finished. And if we've got the data behind it, and so this is a kind of very simple process flow. What these bands are showing you is the percentage of work, or the probability of work getting through each stage, and how old it should be at the different stages in the process. So again, the dots represent a piece of work. Actually, where you've got a dot with a little 4 just means that dot represents 4 pieces of work. That's what the 4 represents. But we can see, again, same data set, so 85% of the work gets done in 16 days. Now we can then work back in the process and say, well, what percentage of work 85% of work gets into testing in how many days? Again, we should be able to look at that, and this is what something like Actionable Agile will automate for you. You can say, well, 85% of the work gets into testing in 14 days, 85% of the work gets into dev in 13 days, 85% of the work in dev active in 10 days, and 85% of the work is in analysis done in 5 days. So now we can start seeing which work is already taking longer than it should. This dot here, in fact, there's three pieces of work that this dot represents, already have a more than 85% chance of taking longer than 16 days. And we can tell that already after, this is 10 and 11 days. So we can start flagging this stuff, and now we can kind of go, okay, let's swarm on this. What's causing this to already start taking longer? Is it blocked? Is there a dependency? Is it just really hard? So we can, focusing on these things that we know are going to take a long time before we finish them, means we can then hopefully rescue it, recover it, so it does get done quicker than it would do. And a lot of teams, these things are probably, this is a demo data set. If you look at this for real data, you just get these items that are up here somewhere because they've just been forgotten about. somebody started them. Actually, something else came up. Nobody was really interested in it. And that's all, well, some of that is skewing the data. So that's kind of where you get into, have you got good enough data to make predictables? But I would argue that that's still representing your system. Now, maybe those things have been forgotten and that not really work in progress. But again, that's probably going to happen in the future, that you're going to start work and forget about them. So that's still time that you're doing. So we can use aging WIP as a leading indicator. So can we do something around measuring aging WIP rather than cycle time? So one of the little dashboards we can look at is what's our average WIP age. So today our average WIP age, so that's looking at the total total age of all the work that started but not finished and doing an average of that. I kind of think I might not do it. I'm surprised that they've done averages here, because generally Dan and that crew are kind of, they kind of quote the floor of averages. It's like, well, if you take an average, you're going to be wrong 50% of the time, which is why we talk about percentiles, because it's you know, it's more, gives us more confidence. But we can look at the WIP age, average WIP age, or some form of aggregate of the WIP age, and see that if that's trending down, we have less aged WIP, then probably we're going to be more predictable. And now we've got multiple ways of doing that, because one, we can just swarm on stuff, or maybe we just reduce our work in process, in which case hopefully things will start flowing more quickly as well. So that's something I've not really kind of tested quite so well, but that's one way of looking at it. And I was chatting with Dan and Pratik about this, and Pratik was coming up with some interesting way. I can't remember what it was, but I think it was looking at, I think he might have even been just recommending just look at, don't even take the average, just look at the total amount of, because effectively to look at total WIP age, you're looking at the total amount of time you've invested in something that you've not yet delivered. So maybe just looking at the total and not worrying about the Agile might be an interesting way of doing it as well. But the other then way is thinking, why does work start aging? It's usually because it gets blocked. Blocked by dependency, blocked by lack of knowledge. There's various ways that we can kind of categorize work gets blocked. So this is from Troy McGuinness. He has a little thing called Blocked App, which gives you data about the amount of work that's blocked and why it's blocked. So this is showing for each week the amount of, so you kind of blockers in progress, the amount of work that's blocked and how long it's been blocked for, and then also the number of items that have been resolved. So tracking that over time and just looking at, are we dealing with our blockers better? If we deal with our blockers better, then we should get work flowing. We're now going to have less aged work in progress, which means our overall cycle times will start coming down, which means we're going to be more predictable. And then this is, the blocker flow is just, it's kind of looking at the net flow, if you like. So this is basically saying more blockers raised than are, more created than resolved. So yeah, more raised than we resolved. And if you're kind of, we're not saying blockers are going to go away, but if we're dealing with blockers effectively, then we should be unblocking things at the same rate that we're blocking them. So if this is constantly high, it just means your number of blockers in progress is going up. I think Troy might say if you're constantly resolving blockers, that might be a bad thing as well. Not entirely sure I agree with him on that, but it probably depends on the context as well. If you've kind of got a team that's just everything's blocked, you probably just want to just get stuff unblocked. But yeah, probably in a healthy system, it probably needs to be reasonably balanced. So that's kind of my hypothesis, really. That's kind of where I'm at with this. So if we kind of start with that idea of measuring blockers, if we measure blockers, then we're going to get less aged work in progress. That's going to lead to fewer long lead time work items or cycle time work items. That's going to make the system more consistent, so it's going to narrow that range, and that's going to make the data more useful for making predictions. And ultimately, yeah, somebody said trust at the beginning, it might have been Andrew. Ultimately, what we're trying to get to is a fairly more subjective measure. Is like, do our executives, do our leaders, do people trust the plans that they're given? You know, that's really what they mean by predictability, is do they trust the plans that they've been given? If we can get to this point where we've got work flowing really quickly and we can show that we're delivering more work more quickly, less days of work in progress, work's not getting blocked, hopefully that'll result in them having more trust. And that's really what I mean by predictability. So I'm going to flip back over to Mentimeter. This is where I'm kind of interested in what you think. So how plausible is that? What do you think of that hypothesis? So I think it's a scale of 1 to 10. All right, okay. Oh, that's good. Nobody's kind of going, well, a load of rubbish. That was a waste of an evening.